Okay, we are going to talk about how you can test for halide ions. So these are the halide ions, the chloride, fluoride, bromide, and iodide. How you can test a sample of aqueous solution you think it might contain those. So what you do is you've actually covered this at GCSE, but just in a bit more detail. Now you add nitric acid. Okay, you acidify the sample first. We'll talk about why you do that in a minute, but it's to avoid false positives. And then you add some silver nitrate solution. Then what happens is, if you get no precipitate at all, it means that there's no halide ions present there. Actually, not quite true, because if there's fluoride ions, you'll also get no precipitate. You can't test for fluoride ions using this method, and we'll talk about why. If you get a white precipitate, it means the chloride is present, and the white precipitate is because you form silver chloride, which is totally insoluble, very insoluble. If you get a cream precipitate, it means bromide's present, and that is because you get a precipitate of AgBr. And if you get a yellow precipitate, it means that you have iodide ions present in your original sample, and the yellow precipitate is because you've got silver iodide there. So all of the silver halides are all very insoluble, and they'll form a precipitate. Let's just have a look at what happens in a precipitation reaction. It's something that usually can cause a bit of confusion. Right, so let's think, say if I had a sample of sodium chloride, an aqueous solution. Well, what I would add to that, I'd add silver nitrate, which is soluble silver compound. That's a colorless solution. And if the chloride is there, so you get AgCl solid forming, and what's left in solution would be sodium nitrate. So if I rewrite that as an ionic equation, you'll see Na plus Cl minus Ag plus NO3 minus nitrate ion goes to AgCl. Now we write, the convention is it's not in solution, so you don't split up into the ions, you write it down as that. That is your precipitate. And you get Na plus and NO3 minus floating around. So you can see the spectator ions are sodium and the nitrate. They don't actually do anything, and that is the reaction that is occurring. So you get aqueous, whenever you get aqueous chloride ions floating around with aqueous silver ions, they'll start to form an ionic lattice, form a solid that will sink to the bottom, and it will look cloudy. Okay, so that is the reaction that's happening there. And of course, with the bromide, it's just going to be, and the iodide, it's going to be the same. So you can have Ag plus ions and Br minus ions. They'll form a precipitate of AgBr solid, and so on. Just say something about a precipitation reaction. It's there's no electrons exchanged, so it's not redox, is it? Because the silver stays as a plus ion, the bromide stays as a Br minus ion. It's not redox. There's no it's not acid base. There's no hydrogen ions exchanged or anything. Really, it's it's almost like it's not a chemical reaction. It's almost like a change of state, because nothing really changes. Those ions come together and form a lattice. So I think of it as not really being a proper chemical reaction, but it's a precipitation reaction. Right, let's talk about why do we add the nitric acid to start off with then. Okay, why do we add that? Well, the reason why I add nitric acid, so why acidify? Right, nitric acid contains H plus ions, and it contains nitrate ions, so the nitrate ions don't do anything. And what the H plus ions will do is they will react with, if you've got in your sample, you've got any hydrogen carbonate, any hydroxide, or any carbonate ions, it will react with them and get rid of them. And the reason why you need to get rid of those ions is because they will form precipitate. So the hydrogen carbonate will react to form silver hydrogen carbonate, which is insoluble. That will react to form silver hydroxide. Sorry, doesn't need a bracket. Silver hydroxide, which is insoluble. And that will react to form silver carbonate, which is also insoluble. Just to give you the equations there, how does the H plus ion, what's it going to do? I'll just rub that out. Okay, so if you add H plus ions to these things, you will get you'll get carbon dioxide and water. Very similar reaction. Oh, actually, you need one there, don't you? Beg your pardon. Here you need two with the carbonate. 2 H plus ions, you're going to get CO2 and water. And of course, with the hydroxide, you're just going to get water. So it gets rid of those. That's why you need to acidify. If you do get a sample of tap water, so you get tap water, right? And you want to test if it's got chloride ions in it. Add a bit of silver nitrate to that. And you'll notice if you do it with most samples of tap water, it will go very cloudy. Okay, I haven't acidified. You get a very heavy precipitate. And most of that precipitate is not silver chloride, because tap water contains a lot of hydrogen carbonate ions. Most of it is actually silver hydrogen carbonate. And you can show that because if you then add a little bit of nitric acid, what happens is you just get most of the precipitate will dissolve, because most of that precipitate is silver hydrogen carbonate. There's only a bit of it, a small amount, is actually silver chloride. Tap water does contain a small concentration of chloride ions. It contains quite a high concentration of hydrogen carbonate ions. So that's just an illustration of why you do need to remember to acidify it. Right, now let's get onto here. You can see here you've got a white precipitate, a cream precipitate, and a yellow precipitate. And there's obviously a bit of confusion there. When is it, so to help you distinguish, then you add to these precipitates, you add ammonia solution. And it's probably best if I do this as a table, what happens at the end. So if you, just to summarize then, if you've got chloride ions, if you've got chloride ions, to do that, right, I'll put fluoride down there. So here's the summary. Got fluoride ions, fluoride, chloride, bromide ions, and iodide ions in aqueous solution. If you add acidified silver nitrate, and then what we're going to do is then add ammonia solution. Let's do, this is a summary, right? So first of all, the fluoride, you'll get no precipitate with the silver nitrate. The chloride, as we said, you'll get a white precipitate. And then to make sure that is chloride, if you add dilute, it will dissolve, dilute ammonia, that will dissolve in dilute ammonia. Bromide, you get a cream precipitate, and that will dissolve only in conc aqueous ammonia. And you probably guessed the trend continues, so you get a yellow precipitate with iodide, and that is insoluble even in conc ammonia. So that is how you distinguish between chloride, bromide, and iodide ions. And if you test a sample, you may think it contains those. You can do that. You can find that out.